Whether a problem tells you to completely factor or not, it really wants you to always completely factor. And so what's involved with completely factoring? Well, basically it's just putting all the things that we've done together so far. The things that you really should check for as you go through and make sure that you have completely factored an expression is, number one, the first thing that you want to do is make sure that your terms are in order. We want our powers of our variables to go from highest to lowest. This is really critical when we do that binomial factoring to make sure that our process works out so that the middle terms are in the middle and all of that from highest to lowest. The second thing that you want to do is make sure that your leading term is positive. So whatever the first value in your expression is after you reorder things does need to be positive. At that same point in time, you should also check for our greatest common factors. If there's something that you can pull out from all of those terms in the expression, you definitely want to do it at this point. It keeps the numbers smaller for our third step, which is if there's a squared term left, you want to try that binomial factoring. For what's left. Okay, so let's give that a whirl here with this so you can kind of see what I'm meaning. For problem number 11, the first thing we want to do is to check to see if the terms are in order from biggest to smallest. So here we have an x squared and then an x and then a number. That looks great. Highest power of x, x to the first power, and then no x at all. So that works really, really well. Here, when we look at our leading term, this 3x squared term, it is in fact positive, so that's good. We don't need to worry about that. At this time, also, you want to check and see, is there a number that would go in, or number or variable combination that would go into all three of these that we can actually pull out and factor? In this case, there is. Notice that there's a 3 that would divide in evenly into all of these expressions. So the first thing that you want to do is pull the 3 out of those parentheses and see what's left behind. When we pull the 3 out from the 3x squared, we're just left with x squared. When we pull the 3 out of a plus 9x, we have a plus 3x. And when we pull the 3 out of a minus 12, we're left with a minus 4. So we were able to, if you look at this expression, now we have our binomial expression. There's still a squared term left, and what we want to do is break that x squared plus 3x minus 4 into 2 sets of parentheses. So we're just kind of concentrating on that part right there. But notice the numbers are smaller, and more importantly, there's no number in front of the x squared, which definitely means that this becomes an easier piece for us to factor. In this case, what we want to do is look at what would multiply to get the first term. To get x squared, we would need an x times an x. Then we need 2 things that are going to multiply to get 4. A negative 4. So we could have negative 2 and 2, or we could have negative 4 and 1. We're not really sure which one would work. If you try a minus 2 and a plus 2, notice when you do your outsides and your insides, here we'd get plus 2x minus 2x, we'd get 0 in the middle, and that is not what we want. So we're not going to want to try the 2 and 2 for this one. Let's try the minus 4 and the 1. So here we can do a minus 4 and a plus 1. When we multiply that out, we get x squared plus x minus 4x minus 4. And combining those middle terms, we get a minus 3x. Close to what we need. We needed plus 3x, so this is the wrong sign. So we can just change those signs inside. Make that an x plus 4 instead of x minus 4, and turn the x plus 1 into an x minus 1. And when you multiply this out, notice you'll get a minus 1x plus 4x, which will get us a positive 3x in the middle. Now, the biggest thing to forget or to remember when you are completely factoring something is if something got pulled out early in the game, make sure it's still part of your answer. We still need that 3 in order to get our final solution. So this is a completely factored expression. We pulled the greatest common factor out first, and then we did our binomial factoring for what was left behind. And that would be your solution. All right, so let's try a few more problems, and essentially we just want to go through this process every single time, and then we get some more practice with our factoring. Right now, looking at problem number 12, things look nice. There's 3 terms there, but they are definitely in a bad order. So we want to write the squared term first. So we'll rewrite this problem as negative x squared, then the x term, so plus 2x, and then the 15, so plus 15. Keep in mind whatever is to the left of each coefficient is part of that number, and so it needs to go along with it. And so now we have this expression that we need to completely factor. At this point, notice that we do have a negative in front of our leading term. We don't like that. So what we're going to need to do is pull a negative outside of the parentheses as part of our completely factoring process. However, that's all that we can pull out. Notice that this has x's and this has x's, but this does not, so we can't pull an x out. This doesn't have any other numbers, so we can't pull anything else out. So that negative is as much as we can pull out as part of this problem. The next thing that we want to do then is go ahead and see what happens when we pull the negative out and when we factor that out. So negative, we'd need a positive x squared. If we pull a negative out of a plus 2x, we'd be left with a minus 2x. And if we pull the negative out of the plus 15, we'd get a minus 15. Essentially, pulling out a negative changes all of the signs, and we've seen that before. If you multiply it all out, that would be negative x squared plus 2x, and then a plus 15 at the back end. So things look good so far. The next thing that we want to do is go ahead and break we do have that x squared trinomial thing here, so we do want to break that down into 2 sets of parentheses. We'll go through. To get the x squared, we'll need x times x. To get the 15, we'll need a 5 and a 3, 1 positive and 1 negative. We can just, again, we're just concentrating on this and seeing if this works. Here we'd get x squared minus 3x plus 5x minus 15. In the middle here, that gave us a plus 2x, right value, but the wrong sign. So we can change these inside things. The x plus 5 becomes x minus 5. And the x plus minus 3 becomes x plus 3. And again, double check. A plus 3x and a minus 5x gives me a minus 2x in the middle, which is what I'm trying to match with here. So we're trying to match we're just focusing on what was left here. So x minus 5 times x plus 3 will get me the x squared minus 2x minus 15. There was that negative sign out in front, so that negative sign out in front does still stay with my final answer, and this is my completely factored form. All right, here's another interesting expression. For number 13, notice that we have 6x squared minus 36x. Highest x term comes first and then the next lower one, so we're good in terms of it being in order. We do, however, have our leading term is positive, but there is a common factor in each of these that we could pull out. 6 will go into both 6 and 36. X will also go into both of these expressions. Notice there's an x in all of those terms there. So for this one, we're going to pull out a 6x and see what we get left with behind. When we pull out a 6x, to get to 6x squared, we'll need another x. And then 6x times, we'll need a minus 6x. Oh, not a minus 6x, just a minus 6. To get to a negative 36x, because we already had the x here. Again, highly encourage you to distribute that back out and make sure that you get what matches. 6x squared minus 36x. So this is factored. Now, at this point, we look at what's left inside. There's no squareds, so we can't do the binomial factoring. So this is as completely factored as this problem can get, and that's fine. 14, we have a similar type of thing here. Our powers are in decreasing order, which is good. Leading term is positive, which is good, but there is a common factor that we can pull out. In this case, 5 will go into both of these, as well as an x, and when we pull that out, 5x times we'll need x squared to get to the 5x to the third. And for the next one, we'll need a minus 25. 5 times 25 gives me 125. We already have the x, so that's that. The difference in this problem is that what's left inside the parentheses here does have a squared term in it. So we are, in fact, going to want to try to break this down into 2 sets of parentheses. Now, something to keep in mind, usually when we do these, we're trying to match a middle term. In this case, there's no middle term, so we want to think of that as a 0x that we're trying to get for our middle terms when we multiply those values out. So here, to get x squared, we'll need an x times x. To get a negative 25, we'll need a plus and a minus. Let's try 5 times 5. And you'll notice as we look at these expressions here, when we do these, multiply this out, you'd get x squared minus 5x on the outside plus 5x on the inside, and a minus 25 at the end. When we put those middle terms together, we get 0x, so we'd end up with just x squared minus 25, which is what we wanted. So that's fantastic, and this expression right here works, and we can stop right away and have found our completely factored solution. Okay. 15 has a slightly strange combination of things here. Notice that we have a squared at the beginning and a squared at the end, but we also have more than one variable. It looks a little bit weird, but we still can work with it just fine. Notice that our x squared term is the highest here, and then a plain x, and then there's no x, so we do consider this in order for ourselves. The next thing that I would look at and check for here is if there's a greatest common factor, and there is. 4 goes into all of those values, so we can pull a 4 out. We can't pull any variables out because this has an x and this has an x, but this only has a y. This has a y and this has a y, but this does not. So there's no variable that's consistent for all 3 terms. So the 4 is as much as we'll be able to pull out. When we take the 4 out, what we're going to be left with is x squared, 4 times x squared to get the 4x squared, a minus 1xy when we pull the 4 out from there, and then a minus 12y squared at the end for this particular part. Okay, so far so good. We have the 4 pulled out in front. We just want to leave that. We do still have a squared term, so we do want to try this binomial factoring thing. For our first positions here, we're looking for things that multiply to get x squared, so we're going to do x times x. For our last positions, we're actually looking for things that are going to get me a negative 12y squared. 3y times 4y would work because we need it to be a negative. We'll need one of them to be positive and one of them to be negative. So here, a negative 3y and a plus 4y will give me a negative 12y squared. So even if you have a different variable that's squared at the end, it's okay. Just make sure that those y's are broken up so that you can see what the term values are. Now, let's double check and see. We're trying to get this to match. Let's see if we found it. So here when we do our multiplying, when we do the outsides, we end up with x squared. Or the firsts, outsides we get plus 4xy, insides we get minus 3xy, and then for the lasts we get minus 12y squared. Putting the middle terms together, we get 1x squared y, which is almost what we wanted. Notice that here we have a minus xy and here we have a plus xy, so we can change the signs to get those middle terms to match because the middle terms were only off by a positive or negative. So what that means is we're going to change the negative 3y to be plus 3y. We're going to change the x plus 4y to be x minus 4y. And if you double check now, we'd get x squared minus 4xy plus 3xy, which combines to give me a negative 1xy, and then the minus 12y squared at the back. So this is going to be my value for factored from this part. We still need to remember to bring the 4 down from up there. And this will be my final solution in completely factored form. Okay, our last example here has several messes that we need to worry about. First of all, notice that the term powers are all out of order. We want to make sure that we start with the highest term. So 12x to the 4th is the highest power. Then that 14x to the 3rd has the next highest power. And then our minus 10x squared is our smallest power in this expression. For this one, now that we've rearranged the terms, our leading term is positive. That's good. We need that. Now, double check to see, is there a greatest common factor? Anything that will go in evenly into all 3 of these terms. 2 will go into all of them, and x will go into all of them. In fact, x squared will go into all of them because this has 2 x's, this has 3 x's, and that has 4. So we can get an x squared out of that whole mess. Now we want to multiply this out. 2x squared times what is going to give me the 6x to the 4th, or the 12x to the 4th. We'll need a 6, and then we'll need an x squared for that. To get from 2x squared to minus 14x to the 3rd, we'll need a minus 7 and another x. For 2x squared to minus 10x squared, we already have the x squared that we need, but we do still need a minus 5. So this becomes the expression that we need to worry about as we go through and do this problem. We do have a number in front of the x squared, so this might be a slightly more complicated factoring procedure Just make sure that you pay attention and try all of your possible combinations as we go. To start with, to get 6x squared, we can try 2x times 3x. Keep in mind that we could also try 6x times 1x. Not sure which one it's going to be. You just kind of have to pick one and try. Then we need to think of things that multiply to get negative 5. So we'll have a negative 1 and 5. And that's the only way to get 5 from whole numbers, so that'll be good. Let's try minus 1 and plus 5 then and see how this works and how close we are to what we need to be. In this case, if we multiply, we're going to end up with 6x squared on the firsts, plus 10x on the outside, minus 3x on the inside, minus 5. That's going to give me a plus 7x on the inside. Oh, nice. So this is a minus 7x. All that's off is that we're only off by a sign. That means we found the right number combination, but our signs were wrong. So we're going to change the 2x minus 1 to 2x plus 1. We're going to change the 3x plus 5 to 3x minus 5. This should now give us the negative 7x in the middle, and I do suggest that you recommend that you double check. 6x squared minus 10x plus 3x will give me a negative 7x and then a minus 5. So that works great. Then don't forget that we did have a leading term out in front. That 2x squared that we pulled out from a common factor needs to be a part of my final answer, and this is my completely factored expression.